Welcome. In this video, we're going to discuss the discriminant. And when we are given the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, the discriminant is identified as that value under the radical, just the b squared minus 4ac. So b squared minus 4ac, that represents what we call the discriminant. It's this piece right here under the radical. And all the discriminant does is it tells us information about what our solutions will look like. So it's really pretty straightforward. If my discriminant, b squared minus 4ac, if it is greater than 0, that means it's positive. And if we have a positive, the square root of, say, 9, we're going to get two unique real solutions. The square root of 9, if we were solving that, we would end up with a plus or minus, and we'd get positive 3 or negative 3. So if we had used the quadratic formula, we might have ended up with 9 under the radical, and that would be positive 3 and negative 3. We have two unique just means different, and they are real number solutions. Now, if we are dealing with the discriminant and we get a value under the radical that is equal to 0. Now notice in the quadratic formula, we would then have plus or minus the square root of 0. So the square root of 0 is just 0. Plus or minus 0 will not change our solution. Add 0 or subtract 0, you're going to get the same number both times. So if the discriminant is equal to 0, we get one repeated or real solution, which we may refer to as a double root. So in a sense, when we're calculating, it looks like we're going to get two solutions, but we would get the same solution twice. So it's a repeated solution, and we learn about that later. That actually has a multiplicity of 2. And then for our last situation, if the discriminant is less than 0. Less than 0 is just our math way of saying we have a negative value under the radical. Well, if I was dealing with the square root of, say, negative 16 under the radical, that would be, and remember there would be a plus minus in front of it, we would get plus minus 4i. So if we have a negative under the discriminant, then we are going to get two unique complex or imaginary solutions. So we will get two different solutions, and those complex solutions are always going to occur in conjugate pairs. All right, so let's look at an example. Here we are just asked to describe the nature of the solutions. So we're given the quadratic equation 6x squared minus x plus 10 is equal to 0. And we don't need to solve this. This question is just saying, hey, what kind of solutions are we going to get? Let's analyze using the discriminant, which is b squared minus 4ac. So my a value, since this is already in standard form, a is 6, b is negative 1, and c is 10. Therefore, b squared, that's negative 1 squared minus 4 times a, 6, times c, positive 10. Negative 1 squared is positive 1, and 4 times 6 times 10, that's going to be 24 times 10, negative 240. So the discriminant in this situation is negative 239. So our discriminant is negative. What does a discriminant value being less than 0, what does that tell us the solutions of this quadratic equation will look like? We know that we're going to have two unique complex solutions. That means we are going to have two imaginary solutions. And so that's the answer I would be checking on the homework. We have two unique solutions which are imaginary or complex. But If we went so far as to actually find those zeros, well, remember, we know that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So by the quadratic formula, that means negative, my b value is negative 1, plus or minus the square root of the discriminant, which we just calculated, was negative 239, all over 2 times my a value, which is 6. So we have positive 1 plus or minus I root 239 over 12. And 239 is a prime number. We can't take the square root of it. We cannot simplify that anymore. So we have 1, again, plus I root 239 all divided by 12, or 1 minus I root 239 divided by 12. And this graph, if we were to graph it, if I took 6x squared minus x plus 10 and plugged it into my graphing calculator, I would get a parabola opening up that never crosses the x-axis. I didn't graph it on my own, so I don't know exactly where it's located, but it would be opening up and it would never cross this x-axis or the line y equals 0. So I hope that helps. This is really just an analytical definition type concept that helps us. And the main idea here is when you're using the quadratic formula, if you recognize that you have a negative under the radical, you automatically know you're going to get two complex or imaginary solutions.